Okay, so I'm back with more DGX Spark related things. So last time we set up Qwen-3 Coder 30B on the DGX Spark, and we tried it through Klein. This time, okay, so since then I actually haven't been using Qwen-3 Coder, but I've actually enjoyed using GPT-OSS 120B for coding related things. I found that it is very fast, given that the Spark is optimized for FP4 and GPT-OSS 120B is also an FP4 native model. It fits very well with the device. And I also had the suspicion as to like why a lot of these reviews, if you watched them on YouTube, for example, always seem to be testing on GPT OSS. I think it's just because everyone thinks that it is indeed a good fit for this device. I am getting about 50 tokens per second generation or so. So yeah, very competent. And I've been playing around with this new app here called Jan, as opposed to LM Studio. So LM Studio is really good for on-device models, right? So if you want to inference with a model that is on your device, LM Studio is pretty good, but I think Jan is very good in that you can add custom model providers, meaning that you can inference models that are remote from your computer. So GPT OSS 120B is something I can't even possibly run on this laptop, but I can if I access it through my Spark here, which I have already configured. Okay. And let's just give an example here and see what we get. Let me just make sure that my appearance is okay. Yeah, let's adjust this to have a large font size. And I think what else do we have here? Let's go for like one dark. No, it's too weird. Let's go for material dark. Okay, cool. All right, so let's ask GPT OSS 120B. How do we implement a basic OpenAI style compatible API minimally with just V1 models and V1 chat completions, and go from there. So, hi, I want to know how to implement an open AI style compatible API with my inference code. I am only able to, let's say, generate text and take in text plus images. The endpoints I would like to implement are V1 models and V1 chat completions. I am using Fast API on Python, and also I want to strive for the simplest implementation possible to just reach minimum compatibility, be concise, and keep everything very simple. Okay, so let's see how fast it can generate. So that's pretty fast, right? So it's going through thinking, and it feels pretty much as fast as like cloud models. I think even faster. So it does give a decent answer. Actually, I've done this question before. So and it does work. So yeah, what you really want to do is when you want to implement an OpenAI style compatible API is that for /v1 models, for instance, you have to be able to return something that looks like this, where each entry in your data keys is the listing of your models available by your server. And then for V1 chat completions, this is more subjective of what you want to include, but things like illicit messages, temperature, where is it? Temperature, max tokens, and whether or not the stream is usually minimal. And so what it really is suppose you have like inferencing code here. You can just basically take in all these properties that are coming in. Let's just say they're like JSON body, right? JSON body, and then it gets decomposed into these properties. What you just need to do is you just need to, I believe, here, return a response that looks like this, right? And that's all there is to it. So you take in this request, which has that JSON body of everything, and then you basically run your inference code right here. So yeah, and then it'll actually the model then just tells you how to use it. And yeah, this is actually a very high quality answer. So I followed it. I was able to implement one, and it is working. So cool. Anyway, so that's GPT-OSS 120B on the Spark. As you can see, it was very fast, 53 tokens per second. And if it does, like, if the chats do get longer, where you have more and more context, it actually doesn't get that much slower, given that there's a lot of really good caching going on. And it's taking up about 75.8 gigabytes out of 120 gigs available. Okay, so next thing, let me actually just kill this now, because I want to go to another thing that I've never tried before. I'm going to try it for the first time on camera, is ComfyUI. So I got like a comment on my last video about doing ComfyUI, and I have I'm not a AI image generation person, so I don't really have much experience for it because I just don't have that interest. So now I am, like, and I, for some reason, right, because I want to test my DGX Spark. So I want to go through this setup guide here live, and just see how far we can get in terms of generating an image. Okay, so I don't know. Yeah, I don't know how it's gonna turn out, but let's do this. Okay, so let's read this line for line. There's also instructions here too. Okay, so let's just go through all of it. Okay, read the docs. So basic idea, ComfyUI. Let me just make this bigger. Okay, ComfyUI is an open source web server application for AI image generation using diffusion-based models like SDXL, Flux, and others. It has a browser-based UI that lets you create, edit, and run image generation and editing workflows with multiple steps. Generation and editing steps, loading a model, adding text, or sampling are configurable in the UI as a node, and you connect nodes with wires to form a workflow. Oh, I think I've seen something like this. This is like a UI that allows you to define your steps as graph vertices and then just like create a flow chart. So ComfyUI uses the host GPU for inference, so you can install it on your Spark and do all of your image generation and editing directly on device. Oh, by the way, go to build.nvidia.com/spark for all this documentation. Okay, workflows are saved as JSON files, so you can version them for future work, collaboration, and reproducibility. So what are we going to accomplish? You'll install and configure ComfyUI on your NVIDIA DGX Spark device so you can use the unified memory to work with large models. That's exciting. So what to know before starting? We have experience working with Python virtual environments and package management. Check. Familiarity with command line operations and terminal usage. Check. Basic understanding of deep learning model deployment and checkpoints, check. Knowledge of container workflows and GPU acceleration concepts, no check, but we'll find out. Understanding of network configuration for accessing web services, yeah, check. Okay, so prerequisites, what do we need to have? We have a Spark, that's good. We have minimum 8 gigs of GPU memory, okay. And then we have at least 20 gigabytes of available storage space. It's pretty new, so we should have some. But even though I already kind of filled it up with some models. We need to have Python 3.8 or higher. The Spark has Python 3.12, so that's good. Pip, CUDA, all this is already built in. And then web browser with access to 8188, which should be no problem. We're on our local area network. Yeah, so all required assets can be found in the ComfyUI repo on GitHub. Okay. So, cool. I'm guessing we just install it. So, yeah, cool. Anyway, time and risk. Estimated time, 30 to 45 minutes, including a model download. Risk level medium. What does risk mean? Like you're going to break your system or something? It's just a Python environment. I feel like we just delete it, right? Or I guess it's because the model downloads are large and you can end up having a partially downloaded model maybe? I don't know. Anyway, yeah. Okay, you just delete the virtual environment if you mess up. Alrighty, let's do it. Instructions. Okay. So check that your NVIDIA Spark device meets the requirements before proceeding. Okay, I think we're all good here. Create the Python virtual environment. Okay, cool. So let's do this. Let's go here and then let's create another one here. Okay, so we'll do make dir ComfyUI, and then we'll go into ComfyUI, and we are going to make ComfyUI virtual environment. So Python 3 mvenv. Let's just call it vvenv. Source.venv bin activate. Okay, so now we're in our virtual environment. What's next? Install PyTorch with CUDA support. Okay, so 12.9. Let's do that. And then what's next after that? We just need to clone the ComfyUI repository. Okay, so let's just do that too while this thing is downloading. Okay, I just need to paste this, right? Okay, so we're doing a lot of things at once just to try and make this faster. Then we'll install the ComfyUI dependencies. So we'll just pip install the requirements. Okay. Let's see. So we're in ComfyUI already. We do want to activate the virtual environment. Oops. There we go. So this is the same virtual environment as the one up top where I'm downloading everything. Okay, so was it pip install -r requirements.txt, because that should be in there. Let's just check just to make sure it is in here indeed. Okay, so pip install -r requirements.txt, and then okay, so PyTorch is installed, so we can just do that. Okay, now let's go back to this pane here. Clear. All right, what's next after that? Download the stable diffusion checkpoint. So we're going to navigate to the checkpoints directory and download the stable diffusion model. Okay, cool. So copy that. And I think the stable diffusion model is like a very basic image generation model probably. So let's go to models. Is there models? Yeah, models. And then I think that's it, right? Okay, models checkpoints. So okay, let's do this. Let's do that, and then we'll just download the model. 2 gigs is not that big for my internet connection. You know what, let's just work with one window now, one pane. Okay, so then we can just launch the ComfyUI server, and then we'll just do curl. I think we just skipped that. Clean up and roll back? Nah. Okay, so we'll just access the web interface, and then we'll load the default workflow, and then we'll click run to generate our own image. Then we'll just monitor GPU usage using NVIDIA SMI in the separate terminal. So here's the thing, it's like this doesn't really tell me much. I like to use HTOP for this, so I think that's what we'll do. Okay, so we're done. We got the model. We got the stable diffusion model. What's next after this? So it was basically launching the server. Python main.py --listen and bind it to all ports here with 0.0.0.0. So is it as easy as this? Okay. And then let's do htop. And you know what? Let's also do NVIDIA SMI. Okay. Oh, that's kind of ugly. Let's see here. I think we just need memory usage, right? So, how do we? Think. Okay. You know what? Yeah, let's just do NVIDIA SMI. It might tell us something. Or not. At least when we look at power usage. Okay, and then we can just go back here and look at the RAM. So, okay, so now we can navigate to 8188. So let's do that. 192.168.1.21 and then 8188. That leads us to ComfyUI. Oh, that's cool. Okay, so what do we do next? This is my first time actually using this. Load the default workflow. But I'm getting this, so should I just close this? Is this the default workflow? No? New? Uh-oh. How do I get back the other thing? Templates? Oh, there we go. So is there like a default? Image generation. Okay. Alright, cool. We have something here. Okay. Okay, so we hit run to generate our first image. So we'll just hit run. So, but what's going on here? I'm lost. How do I move my mouse? Is it just moving? Okay, cool. So what's going on here? So this is a note. Okay, so this is load the model. So we're loading this Stable Diffusion XL 1.5 pruned whatever FP16 model, and then here's the prompt. Okay, so this is how you build a prompt. So you have a positive prompt, tells the model what you want to see. Then you have a negative prompt, you tell the models what you don't want to see. So do this, don't do this. Okay, so okay, short, clear prompts and simple concepts. It has a natural, realistic visual style. So okay, let's just give that prompt. And then the negative, is this a negative or is it conditioning? What is this? There's a, I don't get it, but it's okay. Is this a negative one right here? I think so. This is probably the negative. You don't, no text and no watermark maybe. And then 512. No, you know what? We have a Spark. Let's make this 1024. Okay, just because I want to see how far we can push it. Oh, it doesn't perform. Okay, never mind. The directions say it doesn't perform on large images. Okay, because it was trained on 512. So we might want to find a better model after this. Anyway. Okay, so what do we do here? What's the note here? K-sampler. I believe this depth is like the higher it is, usually the better quality the image is. So let's just do 50. And then CFG, I think this is like how, or we can just hover. Classifier free guidance scale balances creativity and appearance to the prompt. Higher values result in images more closely matching to the prompt. However, too high values will negatively impact quality. So let's just leave that for now. And then let's just leave the rest as default. And then we can save the image as what? Test. Okay, SD 1.5 is our prefix, I guess so. Image will be auto-save to the ComfyUI output folder. You can also right-click and save image. Okay, that's easy. Okay, let's just run. Okay, so now we're running. And I guess we have a queue here. And then if we go back to this thing, we're loading. I guess this is just actually the steps. And we did that in 12 seconds. That is super fast. Wow. That was very fast. And that is a pretty cool thing. I don't generate images often, so I'm easily wowed right now. Cool. Can we do something else? Can we do something like a cat sitting on a desktop gaming computer with RGB lights? Okay. Taking a nap, looking very comfortable and warm. Okay, I guess I'll just leave this here. Okay, so let's do that. It should be very fast. I wouldn't even bother looking at the Spark, but I guess we should look at some stats. Well, hold on, I missed it because I'm slow. But it is taking up like 7 gigs of total RAM, including the OS. I should just keep it like this. Okay. So our cat looks like this, but it looks like it got cut off. And I don't know what this thing is. What is this thing? I said desktop gaming computer, but maybe that was not clear. Let's see, gaming desktop computer. Let's see, gaming desktop computer, and let's take away a cat taking a nap. I guess this was confusing on a gaming computer. Looks comfortable and warm. Okay, let's try that. And while that's going, we can check the memory usage. Okay, 8.62. 77 watts, so very low energy. Did it in 8 seconds. And this looks better. I like this one. Looks a little fake, but yeah, it's not really on a desktop computer, but it's there. So I wonder if we have different types of models we can use. Let's see. We have some LoRa's. I don't know what that means. Checkpoints. Is there a way we can download something like Qwen-Image maybe? Let's see. Okay, yeah, let's do that. So let's do Qwen-Image on ComfyUI. Let's see. Qwen-Image ComfyUI native workflow example. So this is actually a big one. This is a 20 billion. So let's see if we could do this one. I guess we'll need some of this stuff here. So workflow file, after updating, you can find the workflow file in the templates, or drag the workflow below into ComfyUI and load it. Okay, so we'll just wget this, download workflow for the Qwen-Image official model. Okay, so we'll copy link address, and then we can just go to here. Let's just cd to ComfyUI, and then wait, what do we do? I don't even know what we're supposed to do. Do we just drag it in? Drag the workflow below into ComfyUI. Okay, so we can download this. Okay, so did we download it? No. Save link as. Okay, so let's download it to our desktop. And then we can just open show in folder. And then just drag it in. Do we just drag it in like this? Oh, cool. All right, so missing models. Let's get it. Download. Oh, wow. Okay, so we had to download locally and then we had to upload again. So that's not what we want. I think we want to copy the URL and then download it like wget right here, right? So models do we do this into? Where do we download it to? Okay, so VAE. So apparently we would download this to VAE. Okay, so put VAE here. So I'm going to wget and then copy URL, Control Shift V. So we can download that. And then we'll also need to download the text encoders. Whoa, 8 gigs. Okay. Text encoders. And then I'm smart enough to figure this out. So that'll be 8 gigs. It's going to be using Qwen 2.5. Okay, and then we have LoRa's. So just download that too. Let me just quit out of here. Was it ComfyUI, models, and then LoRa's, which wget this one. And then finally, the big one, the diffusion models. Okay, so I'm gonna just go back here, maybe quit out this one. Don't laugh at my skills. Okay, wget all of that. Did I copy the URL? No, I didn't. Okay, so that's all gonna take a while. So I'll resume the recording once all that is done, and then we can go back and resume this and see what other high quality images we can get. We can probably run the cat thing again and see what happens. So yeah, this one's gonna take a long time. It's gonna be like at least 6 minutes. So I'll pause the recording and come back later. Okay, so I think everything is downloaded already, and I hope all I have to do here I hope all I had to do is just refresh, maybe, and then the workflow might be there. Could be. There we go. Okay. Oh wow, this is way different. Well, it's a different prompt. So this is the negative prompt, and then this is a lot of stuff. I think it's just for the example. So I want to go back here, and how do I get back? Was there? Okay, whatever. Let's just do it again. Okay. Yeah. Show flat list. Okay. I guess we lost it. I don't know how to get back the old stuff. Okay, whatever. Yeah, let's do this. A cat taking a nap on top of a gaming desktop computer. How about a cat? Yeah, taking a nap on top of a desktop gaming computer, looking very warm and cozy. Okay, not exactly the same prompt, but let's see the difference in quality. You know what? Let's crank this up. Let's crank this up to 100. Yeah, let's take it to 100. Let's do this, and then CFG. Let's just do 5. I don't know. We'll probably have to play around with that. Wait, hold on. 5. Okay, there we go. Everything else, whatever. Okay, so what else do we need to do? Yeah, we just hit run, right? So we hit run here. That's going to load a bunch of stuff. Let's do htop. So now we're using 37, 38, 39, 40 gigs. 32. Okay, so I bet it's gonna just hover around like 30-ish gigs of memory. And now we're processing our image. And let's see how long it's going to take, because it is a bigger model. That was like a 19 gigabyte model download. And so, yeah, I wouldn't be surprised if this is going to take for the rest of the night. So, let's see. Okay, well, it's going to take 30 minutes. I guess we can just sit tight. Okay, so we're using about 34 gigs of memory stable. And then as far as CPU goes, it's really hard to tell, right? Like, does NVTop tell us anything? Yeah, so we're using about 80% of our GPU here. So we are doing some work. Let me go and touch the Spark, see if it's like warm, and I'll be back. Yeah, it's warm to the touch, but not hot at all. So yeah, we'll let this run, and we'll see what comes out of it. Again, I'll pause the recording. So it looks like we'll be finishing up soon. I hope doing 100 of these steps was actually worth it. So WAN VAE, 0 models unloaded, loaded partially. Prompt executed in about 12 minutes. So it took 12 minutes. Okay, let's see what do we have. Oh, that is amazing. Wow. Wow, Qwen-Image. That's Qwen-Image for you right there. It even got the RGB, even though I didn't ask for it. And I think, I'm not sure what logo this is. It looks very familiar. I think it's like, it looks like Zotac. But yeah, this I like. This I am going to save, and it's large too. It's nice, high quality. Yeah, way better than Stable Diffusion. This is what Stable Diffusion gave. This is what Qwen-Image gave out. Yeah, so very high quality image. Took 12 minutes. I was able to do it without even worrying about memory. That's like a new thing. Like running AI, I'm always worried about memory, but with the Spark, didn't even have to worry about memory right here. And I suppose the same feeling, I would get the same feeling with Strix Halo. Like, let's say I had a framework desktop, for example, or one of those GMK Tech devices. I think I would feel the same way. And I hope like one day I will be getting one of those to test. But my focus right now is just more on development. So if I run into one, I'll definitely give this scenario a try too. Anyway, so that's it for today. We're diving in more and more into just like playing around, and hopefully we'll try other things here in this playbook. So let's see what else we have. Yeah, we have to mess around with the dashboard, and we already know Open Web UI. I don't know. Maybe quantization? Quantize a model to NVFP4 to run Spark using TensorRT model optimizer. Yeah, maybe we'll do that. Yeah, and fine tuning. Definitely fine tuning. Okay. That's it. Thanks.